So Marlo wants to play with his remote controlled car and learn physics. He records the position of the car at different times. Okay, so draw the position versus time graph with the appropriate line of best fit. So given this graph here, try to check which one is your independent and your dependent variable. In this case, the independent variable is the time, and this would be your dependent variable. Okay, so that means that I'm gonna plot in terms of position along the y. So I make use of this whole thing here, and then in the x would be my time. By the way, I think just bring a ruler during our unit test so that you can have a very nice straight line. So again, they have a common 0, or the origin is common for both. Okay, you can have different scale for your time and for your position, but just try to remember that the starting point is the same. It should be at the center, or the point of the intersection between your y-axis and the x-axis. So therefore, independent variable should be placed along x. So I'm gonna place this one here, time. The unit should be in bracket. So second, so the quantity time, and then place in a bracket your unit of second. And then for y, this should be position, and then the unit is meter. And well, the title is just given here. Or again, the general form of the title is just the y variable, just place the y variable versus the time. So in this case, the y variable is position. So the title is versus time. Okay, so my title is just the one that is given there. So that's the title of my graph. Now I need to, before I can plot, I need to have my scale for both x and y, or for both times and position. So if I'm gonna look at the time, maximum is 11.5, and then my minimum is 0. So depending on the space that you're given, okay, just try to take note. Well, do you think I can reach to, or is this enough for me to use every line as 1 second? Well, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, that's enough. So therefore, I'm going to use a scale of 1.0, 1, 2.0, 3.0, 4.0, 5.0, 6.0, 7.0, 8.0, 9.0, 10.0, then 11.0, then 12.0. Okay. For the position, on the other hand, I can use 3. Well, 1, 2, 3, 4, 5. I can use 5. 1, 2, 3, 4, 5. This is 10. Then 1, 2, 3, 4, 5. This is 15. Okay. So 15.0, just indicating the same precision of each measurement. Okay, there. That would be my scale. So now that you have your scale, you can now plot. So I'm gonna start with 0, 0. So I have a point at 0, 0, and then at 1 second it's 1.3. So 1.3 is somewhere here, and then at 2 sec it's 2.5. 2.5 is 3.3. So 1, 2, 3.3. So it's somewhere here. Again, you can approximate that one. Again, you don't have to place the exact value that is in your table here, since 2.5 is between 2 and 3. So you can just plot the value of your point in between 2 and 3, and then the value of position is 3.3. So just count 1, 2, 3. So it should be more than 3. So that would be around that particular area. And then 3.9. 3.9 is close to 4. So I can approximate that one, this line here. And then that's 5.1. So just a little bit over 5. Okay. So that's my next point. 5.5. 5.5 is between 5 and 6. And that's 7.2. So 7.2 is just a little bit over of the value of 7. And then time of 8.1. So 8.1 is just a little bit over of this line here. And then the value of my y is 10. So that would be somewhere 8.1 is 10.5. So in between 10 and 11. So maybe somewhere here. Okay. And then lastly, you have 11.5. Then it should be at 15. So somewhere 11, and then 11.5, and then 15. It should be somewhere here. So this is how you plot your data points. Next is you are asked to draw the best appropriate line, that best fit, or the curve that should represent your data point. So if you can see here, you can use a ruler. Well, by just looking at that one, somehow that is just a straight line. So therefore, I can write my data points. So again, in your line of best fit, it doesn't have to hit all of your data points. Okay, so maybe I can use that part there. Oops. Okay, maybe that one, and then I'm gonna draw my line. Okay. So that would be that would be your graph. That means that you're done graphing, but you also need to determine the slope. Okay, you need to determine the slope. So I'm gonna choose. So in determining the slope, choose 2 points. So 2 points that hits this particular line, the green one. So if you can see, so the slope is you choose 2 points between the one that hits this green line here. So I'm gonna choose this one because this is just 0 and 0. That would be my P1. The second point, I'll choose this one. Anyway, this actual data point hits that average line that I have. So that is the value of that is 5.5. So this would be my P2. The value of X is 5.5 second, and then the Y value is 7.2 meter. Okay. So again, in determining the slope, I need to have 2 points. The first point is 0, 0, as indicated in my drawing there. My second point is from the actual data point, although I can also use other data points, okay? But just remember that it should be coming from a point that hits your green line here, the line of best fit. So for the slope, the general formula for the slope is just y2 minus y1 all over x2 minus x1. So remember that this is my x1, this is my y1, this is my x2, this is my y2. So y2 is 7.2 meter minus 0.0 meter all over x2, that's 5.5 seconds, minus 0.0 seconds. So this should be 7.2 meters all over 5.5 seconds. So for the slope, that should give me 7.2 divided by 5.5. It's 1.309. But if you can see here, both have 2 significant digits. So the final answer has 2 significant digits. So meters, 1.3 meters per second. So that answers your letter B question. The slope is 1.3, but remember, it should have a corresponding unit also. So the unit is meters per second. And okay, for number 7, this is more of, if you can see, you need to employ the correct way of expressing your final answer in the correct number of significant digits. So for letter A, 15.383. And then this is addition. So it's much easier if you're going to write this given in vertical form, like 4.8. I think you are being taught in your grade, maybe grade 4, grade 5 math, that if you are adding or subtracting decimal numbers, you have to align them. So align the place value. So you also do that one. This is 3, 8, 11, carry 1, that's 6, 10. Then the decimal point is just the same thing as that. That would be 20.183. However, the least precise is only up to here. So this is the least precise. So for the least precise one, the final answer should be 20.2 something. Well, in this case, it doesn't have any unit. So the final answer is 20.2. So the least precise. So you're going to round off up to here. Rounded up to 1 decimal place. Because the reason for that being is that the least precise one is 1 decimal place. So for letter B, it's subtraction. So same thing. It's much easier, or actually you can also do this one in your calculator. But to identify the number of significant digits of your final answer, or in this case, the number of decimal places, it is much easier if you're going to do it vertically, or this operation here. This is 8, this is 10, this is 7, that's 4, then this is 8, this is 4. Okay, so 48.47. Then again, the least precise one has 1 decimal place, so the final answer should be 48.5. So now for letter C, For letter C, you're gonna take note of the number of significant digits. So let's say for 6.83 times 10 to the power of 3 multiplied by 3.1 times 10 to the power of -2. Well, you count the number of significant digits. This has 3 significant digits. This has 2 significant digits. So the answer here should have 2 significant figures or digits. So just do that one in your calculator, and that should give you an answer of, well, your calculator might give you this, the whole answer, but you're gonna cut off in 2 sig figs. So that would be 2.1 times 10 to the power of 2, or this is just equivalent to 210. Okay, 2 sig figs. The final answer should have 2 sig figs. And then for letter D, so you have that divided by that. So this has 3 sig figs. This has 4 sig figs. So the answer should have 3 sig figs. So doing that one in your calculator, that should give you 7.74 times 10 to the power of -4. So this has 3 sig figs.